Hello, today we are talking about the quotient rule, which is not exactly like, but is in the same genre as the product rule. So we had learned about the product rule, but we also have not taken the derivative of a quotient. A quotient is when we're dividing two functions. So in this function right here, it's a quotient because we are dividing x squared by tangent of x. So we're going to look at the same same function we looked at with the the product rule. We started out looking at this function, and we looked at how we would take that derivative just using our regular power rule, and then we also are going to take the derivative by looking at this quotient over here. Now this is the same as x to the fifth because it's x to the seventh times x to the negative 2, because that x squared is in the denominator. And when I add those exponents together, that does give me x to the fifth. So these two functions are the same, they just look different. So again, we've already seen this derivative, and using the power rule, the derivative of x to the fifth is 5x to the fourth. So now I'm going to do the quotient rule to the right. And so just kind of bear with me. I'm going to use a couple of different colors. I'm going to call that top blue, and I'm going to call the bottom red. So my derivative is going to be the bottom, which is x squared, times the derivative of the top, which is 7x to the sixth. I'm going to subtract top x to the seventh times the derivative of the bottom times 2x. And I'm going to divide all of that whole thing, by the exact same bottom that I had before, my same denominator, squared. So at first glance, this does not look like this is going to turn into this over here. But let's do some simplification and see what we get. So this is the same as 7x to the eighth minus 2x to the eighth, because x to the seventh times x to the first is x to the eighth, all over x to the fourth. So from here on the top, I can combine those like terms, and that gives me 5x to the eighth over x to the fourth. So we can see where my 5 is going to come from. That's going to be there. And then if we look at this right here, we should be able to simplify that. I have an x to the eighth on top and an x to the fourth on the bottom. And when I simplify that, I get a single x to the fourth on the top. And those are the same derivative. So this derivative is the same as this derivative. So just want to show you that the quotient rule does work, and it gives me an accurate derivative. So let's look at writing that quotient rule. And again, I'm going to write in words that I used. And the words I used was, I took the bottom and I multiply that by the derivative of the top, and then I subtract the top times the derivative of the bottom. And then I divide that whole thing by the bottom squared. Now this is a rule you need to memorize, and it doesn't matter how you memorize it. Either you talk yourself through it with the words, or we can look at the symbols. If I look at the symbols, again, I'm going to write in some colors. I have U, and then I have a V on the bottom. So if I were to write the derivative in symbols, that would be the bottom times the derivative of the top. I'm just going to call that U prime, minus the top times the derivative of the bottom, and again I'm going to call that V prime, and that is all over the bottom squared. And again, whichever way you would like to look at it, you just need to memorize it. So what I'd like you to do right now is I would like for you to do this U try, so give it a go. Please pause the video here to complete the U try. here's the solution to the u-try, the answer. So please take a moment to check your answer. If you have any mistakes, please pause the video here to make corrections. If your answer was good, we're going to move on to the next one. I'm going to scroll down. So now we have this derivative, and not only do we have a top and a bottom, but we also have a chain rule with the top. So I'm going to rewrite my top as the sine of 5x. So there's my inside right there. And I'm dividing by my bottom, which is 8x minus 3. So go ahead and take our derivative. And again, I start with the bottom. And that bottom does need to be in parentheses because the whole 8x minus 3 is what we're multiplying by. Times the derivative of the top. So the first part of my top is sine. So the derivative of sine is cosine of the same thing of 5x. And then I need to multiply that by the derivative of my inside. And the derivative of my inside is 5. Then I subtract top times the derivative of the bottom, and the derivative of the bottom is just 8 using a power rule, all divided by the bottom squared. And we can just leave our answer just like that. So moving on to the next one. Next one is one that I would like you to try. And again, it's just a quotient rule with a chain rule in the top and a chain rule in the bottom. So go ahead and pause the video here to complete u-try 1. Here is the answer to u-try 1. Now, if any part of yours is incorrect, please pause the video here to make corrections. If your answer is correct, what I would like for you to do now with your answer is to give it a go in trying to simplify this. So for example, in the top 2 terms, there's only 2 terms in the top, you can factor out a GCF, and then part of that GCF will simplify with the denominator. So please pause the video here to try to simplify your answer. So I've drawn a little squiggly line to separate my original answer from my more simplified answer. Now, in this answer, I've shown you 2 steps. One where I pulled out the GCF of the top, and then I used the square brackets for what was left inside. And then I simplified that by reducing the top and the numerator and the denominator of my fraction. What I didn't do was show you that we could have also combined like terms in here, which again I didn't do, but you probably should have. A multiple choice answer would have had the red bracketed part also simplified. So moving on, let's go to example 2. If you need to work on that simplification, sorry, please pause the video. I'm now moving on to example 2. It's going to be a long one, so don't write too large. So our derivative in this case, color. Let me transfer my top into some colors here. My top, the outer part, is my log base 2. Sorry, let me change my pen. And then my inner part is x squared minus 3x. And then I'm dividing by my outer part of my denominator is cosecant inverse of my inner part is actually 2 inner parts, but I'm running out of colors, so I'm going to write it all as 1 inner part, and that is going to be 3x plus 2, which is my inner part, raised to the 1/2, which is sort of the middle inner part, and that's what I have. So taking my derivative now, I take the bottom, which is cosecant inverse of, I'm just going to leave it as the square root of 3x plus 2, because I don't need this calculus friendly here, I'm just writing down the bottom, times the derivative of the top, and the derivative of the top is 1 over my inside, which is x squared minus 3x, and times the natural log of 2, and again that was 1 over, just to make sure I had enough space there. Then I need to multiply by the derivative of my inside, which is the green part, and the derivative of the green part is 2x minus 3. So what I've done so far is, in red I have the bottom, in the blue and green I have the derivative of the top. Now I need to subtract the top, and again I'm leaving it all one color, times the derivative of the bottom. So the derivative of the bottom, I'm going to have the absolute value on the bottom, so I'm going to have a large fraction here. The absolute value of my 3x plus 2 to the 1/2 times the square root, I'm out of room, the square root of this square root of 3x plus 2, that whole thing is going to be squared, and then I subtract 1, and again this is a 1 on top, and this was a cosecant, so that's actually a negative 1 on top. So now I take this and I multiply by the derivative of my inside. If you recall, I just went ahead and left the whole inside purple. So that whole purple part in the what I rewrote is my inside, so I need to multiply by 1/2 times 3x plus 2 raised to the negative 1/2, and then times the derivative of that inside, which again I apologize I didn't have another color to use, times 3. So I have done, let's see what I've done. The bottom times the derivative of the top minus the top times the derivative of the bottom, all divided by the bottom squared. So that's my cosecant, that's not an S, cosecant inverse of the square root of 3x plus 2. That whole thing is squared. That's my cosecant right here. So this is a big mess, and we're not going to do anything with it, but that is the derivative for example 2. So moving on to the next one, I'll leave my example up there. I would like for you to do you try 2. Again, please go ahead and give it a go. Please pause the video here to complete you try 2. Here is the solution to you try 2. So please check your answer. If you have any issues with the answer, please pause the video here to work through those. If your answer is correct, we're moving on to example 3. Scrolling down. So here we are at example 3. Now this one is a little bit different because I have an outside that has nothing to do with the quotient, and my inside is the quotient. Okay, so that's what the difference is in this one. And again, this one I'm going to run out of space. So if I don't really have enough colors to sort of rewrite all of this, so I have cosecant of, on the top, the very outside is natural log, and the inside I'm going to rewrite, because I'm probably going to use log rules to deal with this. It's the natural log of 4x squared minus 9x, and that whole thing is raised to the 1/3. And then the denominator I have is 9x minus 1 is my inside, and it's raised to the 4th power. So when I go to deal with my natural log derivative part, I'm going to go ahead and rewrite this as, now this is not a derivative, this is just using my log rules. I'm going to rewrite that as 1/3 natural log of 4x squared minus 9x. Again, that's not a derivative, that is just rewriting the top using my log rules. So let's go ahead and get started with doing our derivative. And again, you're going to just squish this. This is going to be really large. Okay, so my derivative is going to be, first I need to deal with this outside. The very outside part is my cosecant. And the derivative of my cosecant is negative cosecant cotangent. So it's going to be negative cosecant of the same thing, natural log of the cubed root of 4x squared minus 9x over 9x minus 1 raised to the 4th. And it's the cosecant of that whole thing times the cotangent of that whole thing. That's a 4. Yeah, that thing you can't read there, that's a 4. Okay, so right now I've done the derivative of the outside, which is negative cosecant of the same thing times the cotangent of the same thing. So now I need to multiply that by the derivative of the inside. So this is where I now have my quotient rule. So I'm multiplying this by bottom times the derivative of the top. And again, I'm moving over to that sidebar here, this version of the top. So that derivative is going to be 1/3 times, the derivative of natural log is 1 over, so my denominator is going to be 4x squared minus 9x. That's the derivative of the natural log. Then the derivative of the green inside is going to be 8x minus 9. So in the blue and green, that's the derivative of the top. Now I need to subtract the top and the cubed root of that. So that's my top times the derivative of the bottom. The derivative of the bottom is 4 times my inside, 9x minus 1 raised to the 3rd, and then times the derivative of the inside, which is times 9. So what I have right now of the derivative of my inside, I have the top times the derivative of the bottom minus the, I did the bottom times the derivative of the top minus the top times the derivative of the bottom, and this is all over the bottom squared. So that would be my 9x minus 1 to the 4th is being squared. So that right there is my derivative. And you'll see on the screen there is a U-try for you to do. So I would like for you to please pause the video and complete U-try 3. Please pause the video now. Here is the answer to U-try 3. So please pause the video and check your answer and correct anything that you need to correct. And have a wonderful evening.